In this video, we're going to talk about functions. This is going to be the first of 3 videos about functions, okay? So functions are really fundamental to our programming in C++. Every program that we've written so far has a main function, the int main, okay? So it's what happens when we first execute the program. So we've already used some built-in functions, such as those from the CMath library, such as the POW function to take a number to another power, and the SQRT function, which is a square root function. Okay. So functions are also a concept that we talk about in mathematics, that if we have a function, we can send it a value and it will return another value. Okay. But they don't line up exactly. So there are differences in how we talk about functions in programming as compared to how you would in mathematics. Okay. But they're a similar concept. So functions in programming are really just pieces of code that we're going to take out of our program and put in a special place, give it a special name, so we can run it again. Okay, so that's the idea. So the book talks about a bunch of built-in functions. They're on page 350 and 349, 350. Okay, and it has some math functions and some character functions. So I'll put a couple of these in here so you can ignore that create a function for the moment. So here I've just got an X and a Y. So I've included the CMath library, and the CC type has those char functions there. So I have an int X equal to 5, int Y equal to -10, and then an int C is equal to A. We've seen this before. So in this case, I'm pulling in the sine function. You can do multiple things. So I'm taking the square root of X and then taking the ceiling function, which is going to raise it to the next whole number. And then I'm doing a 2 upper on this character C. Characters are weird in that when you do this, and I'll run this real quick to show all of these, it gives us a sign, no problem. It gives us the upper of the square root of that number, which is correct. But for the 2 upper, it gives us a 65. Okay, so it turns out the return value type there is an integer, which is a little bit strange. Okay, but yeah, it is what it is on those. So in addition to that, we can create our own functions. Those are called user-defined functions. And with user-defined functions, they come in 2 varieties. Either they're a value returning function, so they return something, or they're a void function and they don't return anything. They just do something else. Okay. So for the value return functions, we have to have a type that's going to return. So it's going to return an integer, it's going to return a double, it's going to return a string or whatever. Okay. Those value returning functions have to have a return statement somewhere in there, or the compiler is going to complain about it. Okay. Of course, void functions don't have a return statement. It would be an error for them to have one. So if you had me for Python, you'll know this already, but I have a golden rule about functions. Your function should not print out anything unless all it does is print out. Okay, so if you create, here in a second, we're going to recreate the absolute value function. You don't want to print out anything in that absolute value function. You just want it to return that value, which you can then use in whatever you want to do it for in your program. Okay, so I think that's important. Okay, so now I've got on the screen here this list of things we need when we're creating a function. So these are creating a value returning function, basically. Function. Okay, so we need the name of the function. The names in the function follow the normal rules of C++. It can't be a reserved name. You can't name a function cout, for example. It has to start with either an underscore or a letter of some sort. Can't have any spaces in it. Certain punctuation it can't have. Okay, so just like we do with variables. I think it's important, just like it is with variables, that the function name be practical, something that you can remember, and short-ish, so not super long. Okay. You then have to have the parameter or parameters you're going to send. Each of those has to have a data type. Okay. And then the function itself returns a data type. So in C++, similar to Python, you can only, actually not similar to Python, in C++, you can only return one thing. Okay. So you can't return multiple things. Okay. So I think in Python you can. And then the code to actually implement, which I left an L out. to implement the function. Okay. So let's get rid of most of what we have here and think about how we may want to create a function. Okay. So let's say that the value comes in from the user input. So we're going to have a C out here, enter a number. Okay. Pretty straightforward. And then another int value up here. Well, let's make it to be y. Okay. Then I'm going to cin to y. Okay. But let's say I only want positive values here. Okay. So now I'm going to need to basically make sure this y is positive. Okay. So to do that, I'm going to say if y is less than or equal to 0. Okay. No, less than or equal to. So let's think about that. What if it is 0? No, I need to just be less than. Okay. If y is less than 0, and again, some of you are not putting brackets in your code, and at some point I will take a point off for that, simply because it makes the code harder to read. And if it's harder for me to read, it's harder for me to grade. And if you have a question, I'm going to ask you to put in brackets before we do anything else. Okay. So if this is the case, y is going to be equal to negative y. Okay. And if not, that's it. That's all I have to do. Okay. So let's say I'm going to ask the user for 10 numbers. Okay. So now I'm going to do the same thing again to do a different number, but it could be the same number in this case. Okay. So let's do it on the X. So let's say neither of these values do anything. Okay. In fact, I'm going to have to not only copy that. Okay. So let's do X first here. X, X, negative X. Okay. I'm going to have to do this as well, right? Every time. So I'm going to have to copy that every time we do our code. And it's going to get really ugly. I should have copied or before I changed. So I have to go through every time and do that, right? So a couple of problems there. First, it's a lot of code to have to recreate. Second, it makes my code really long and kind of ugly and hard to read. And it introduces the chance I'm going to make an error. Okay. So this is the prime example where I want to create my own function. Okay. So I'm going to create my function outside of int main. You don't want to create a function within a function. Okay. And we start with, we're going to call this function ABS. Even though there's already an ABS in C math, which we're including, this will overwrite that. Okay. In fact, I don't need to include either of those anymore, I don't think. So let me just get rid of those for now, but it wouldn't matter. Okay. So I need to say the return type. It's going to be an integer. Okay. I then need a parameter. Let's call it number. And then I need a type for that. It's going to be an int number. Okay. So the number is what we're going to come in. I like to go ahead and type in return right there, just so I won't forget. Okay. So again, this function, actually I'm gonna do it once without so we can see. This function call here by saying int ABS, we're making a promise to the compiler that we're going to send it something back. Okay. So I can go down here now and basically copy this code. It won't be exact, it'll be close enough. Okay, what we want to do here. Okay, so copy that up here, but I'm going to use number instead. Okay, so if number is less than 0, the number is equal to negative number. Okay. And that's all we're going to do. Okay, we're missing the return. So when we go to compile this, it's going to give us this error. No return statement. Okay. It says returning a non-void. So we didn't say void. Okay. So I have to go back through and put in return number. Okay. Okay. And that should work. We haven't used it yet, but it should compile correctly, and it does. Okay. So Yeah, I'm not doing it yet. We don't care about that. Okay. That's what I meant to do. Okay. So now we have this function. It's important to realize that number is a local variable, which means it only has value here in the ABS function. Okay. So if I would come down here and let's get rid of things that we don't need. So I don't need this anymore. And I don't need this anymore. Let's say I just see out number, right? It's defined up there. Spell it correctly though, or type it correctly. Let's do that, see what happens. Gonna give me an error. It doesn't know what number is. And notice what it says. It says number was not declared in this scope. It doesn't say it wasn't declared because it is. It, in essence, the declaration happens right here. This is our int number. Okay. Happens as a parameter, but it was not declared in main. It was declared in ABS. Okay. So I can't do that. Okay. So now when I've entered these numbers, I can go ahead and say x is equal to the ABS of x. Down here, I can say y is equal to the ABS of y. Okay. And then I can see out x tab y. Okay. So run this, compile it, run it, enter a number. So I enter a -3. So I enter a 5. It's going to give me a 3 and a 5, which is correct. Okay. So that's the basic idea behind creating a function. Okay. And again, for now, we're going to get a technique to not have to do this. We have to define our function before we can use it. Okay. So the first thing that the program does when we run is run main. Okay. But it's going to scan from top to bottom to get there. So when it starts, it's going to start up here and say, oh, that's a comment we don't care about. Here's the include IOStream. Let's include IOStream. Okay. Now namespace is going to be standard. We're going to have that the default. These are comments we don't care. Okay. Here's a function called ABS. I don't run it yet, but now I know where it's at. I know what it's what return type and what it takes. So I know there's a memory location for this function now. Okay. Now I go to int main and start working. So when I get to this line here, the ABS is like, oh, I know where that's at and I can do it. Okay. So there's a way to define them at the end, but for now, you have to define them before the int main. Okay. So the next thing I'm going to do, we'll do another example here for a different kind of a function. Okay. Well, no, one more thing. I want to talk about the difference between actual and formal parameters. Okay. So in our ABS function, the formal parameter is number. Okay. It's an integer. The actual parameters relate to the call. So in this case, the actual parameter is the X that we enter. So whatever number. If I did -5, then the actual parameter is a -5. Okay. So we're going to create another function here. In this case, again, not a super useful function, but we're going to call it, we want it to be a double function that takes two doubles and returns which one's bigger. Okay. So I start with my return type of the function is double. Okay. I call this one larger. My parameters are going to be a double X and a double Y. Okay. In this function, I'm going to declare another variable, call it double max. Okay. This variable also has a scope only inside of larger. That's it. Okay. I'm then going to say if X is greater than or equal to Y, the equal could be either place. Then I'm going to set max equal to X, else I'm going to set max equal to Y. Okay. And again, I say equal, but that's really the wrong thing. I should say assign. I'm assigning max to X in the first case. If not, I'm assigning max to Y. Okay. No equality here. Okay. So when I'm done, I have to make sure I'm going to return that max. Okay. That's it. Should be good. Okay. We can compile it first because it doesn't make sense to run it unless you know that it works. Seems okay. So I don't need to test it because I didn't do anything. Okay. So I can go down here and I have them entering the two numbers. So I can go ahead and figure out the larger one. Okay. So again, with the value returning function, I have to either print it out or set it to a variable or use it in a function call or something else. Okay. If I just say, look, I just find my home keys. Home keys are your friend. If I say larger x, y, okay, and that's all I do. Note, just so you know, the x and y here are not the x and y in the larger function. They have their own version of it. Okay. So they're not the same version at all. Okay. So changes to x here do not make changes to x back here. Okay. But just, and I'll show that in a second. So if we just do this, if we run it, compile it, and we run it, whatever we enter 4 or 5, it didn't do anything. Actually, it did something. It still had to call and do all this work, but it didn't show anything. We didn't capture the value of the function. Okay. So I would have to either, I could print out, it's fine. I could say print out the largest of these is, and then print out the larger there. I could also set that equal to a variable. Okay. So let's try that, see if that works. Got to recompile it, got to run it. Okay, enter a number. If I enter a 10 and I enter a 20, the largest of these is 20. Okay, so that works. Okay. So let's just show this idea of no side effects. Okay. So we've seen we can't see number outside of ABS. We haven't declared it. We can't see larger outside of the double. But these X and Y that we're sending in, what if I make a change here? What if I say something like X is equal to 1,000? Okay. So if this were the same X, then if I entered X to be something and Y to be something less than 1,000, the 1,000 is going to be the biggest number, right? Let's see what it does. Compile it, run it. I'm going to say 4 and 6. So the largest number here is 6, right? So what it means is that this value here, when I set X to be 1,000, doesn't have any side effects. It doesn't affect the X we have in our main program. So even though it's the X that we sent in at the top, okay, so this gets to a concept we'll talk about more later, and that we're passing by value. We're not sending the memory. Remember what X is. X is a memory location that holds a value. Okay, it has an address. We refer to it as X. In this function now, what we're doing, we're sending the value stored at that memory location, not the address to the memory location. Okay. So there are no side effects from this code. Okay. And the last thing I'm going to do in this video, I want to look at, and again, it's a function that doesn't make a lot of sense. Once you create a function, you can use a function in another function. Okay. So if I have this double function, another double function called compare3, it's going to take a double x, a double y, and a double, if I can type double correctly, double z. Okay. Again, I want it to do returns. I'm going to go ahead and put that return in there now. Okay. So again, this X, Y, and Z is not the X, Y, and Z either in larger or in main. They're all their own separate things. Okay. So in this case, I'm going to go ahead and I'm going to do as a return, and it's okay to do a one-line return or one-line function here. I'm going to return the larger between X and the larger of Y and Z. Okay. So when it runs this, it's first going to call larger on Y and Z, take the largest, replace it here with that value, and then run the larger on X and that largest value there to get the largest value. Okay. So I can just put in here, just so we know, it Z is equal to 100. So it'll be the largest. Shouldn't matter. Okay. And then I'm just going to not make it pretty. So I'm just going to say compare 3 with X, Y, and Z. And that's it. Okay. So let's call that, compile it, run it. 4 and a 5. And the largest of these, the 4 and the 5, is 5. But comparing the 3 gives us 100. Okay. And just so we're clear on this, I didn't need to call this X and Y. Okay. So even though my variables in main are X and Y, again, to show they're totally separate, let's just change this. Okay. So I'm going to change this to an A and a B. Okay. Then if A is less or greater than or equal to B, then max is equal to A, else X, max is equal to B. Okay. So this has no bearing at all on the function. We run it into a 4 and a 5. It still works perfectly. Okay. So you don't have to name your parameters the same thing as they are in your main program. Okay. So I think that's enough to get us started with functions. So at this point, it's worth doing some exercises with functions to get a better idea as to how they work.